Hey there, welcome back to solving proportions with rational equations. We're going to go ahead and look at solving linear equations that result from proportions, kind of part two of this solving proportions topic, okay? So we're here solving proportions by using cross multiplication. You'll be successful if you can cross multiply, you can solve resulting linear equations, and you can determine if the equation has no solution or infinitely many solutions. So let's go ahead and take a look. Prior knowledge, if we want to go ahead and solve an equation just like this, 3 over 2x is equal to 15 over 8. What we would do is we would go ahead and cross multiply. I have 3 times 8, right, the good old butterfly method, times 2x, 2x times 15, 2x times 15, so 2x times 15. And what we get from this is we get 24 is equal to 30x, okay? And we can go ahead and we can divide both sides by 30, and we get a solution here. So we get x is equal to 24 over 30, which both of those can reduce by 6, so we get 4/5, okay? Now, it's very, very important to remember that the denominators cannot be equal to 0. So when you have whole numbers down here, it's very simple. And if you just have an x, it's very simple. Hey, x can't be equal to 0. But sometimes I get other values. And so like here, right, if I plug in 0 into x, that creates a problem. We cannot divide by 0. So 0 is what we call an excluded value. I cannot have an excluded value in there, okay? And that will appear coming up. But we have another concept that's very similar. What if I have a situation where I can have infinite solutions? So what if an equation, there's more than one, or there's infinite amounts of solutions? Or what if I get an equation that's broken, where there is no solution? So both are possible. Let's check them out, okay? Here we go. An equation has infinitely many solutions when the result is a true mathematical statement, such as 2 equals 2. Duh. -5 equals -5. Yes. Or x plus 3 equals x plus 3. This means that regardless of whatever you plug in for x, it's true. So if you get a statement where the left side's equal to the right side, always infinite solutions. What about a broken statement, a false statement? So we covered true. Hey, this is true. Infinite solutions. What about false? That would be no solution. And an example of this would be 2 equals 3. 5 equals -5. No value of x will ever make this true. So let's go ahead and let's look at some examples here. Solve the equation, show the work that leads to your answer. Example 1, x plus 1 over x minus 1 is equal to 7. Okay, so again, I'm going to go ahead, I'm going to cross multiply here. I get x plus 1 is equal to 7 times x minus 1. I'm going to multiply both sides by x minus 1. Okay, this cancels here, this cancels here, and we can go ahead and distribute. So I get x plus 1 is equal to 7x minus 7, and this is a linear equation. I have to go ahead and move all of my variables over to one side. So I'm going to pick the right-hand side. I like the right-hand side. Let's keep all of the x's positive. So these cancel. We get 1 is equal to 6x minus 7, and then we'll move this 7 over here. So add 7, and we get 8 is equal to 6x. Okay, we'll go ahead and we'll divide here. Divide both sides by 6, divide by 6, and we get x is equal to 8 over 6, which we can reduce by 2. This is 4/3. Okay, so this is a variable equals an answer, one solution. This is neither of the infinite cases or the no solution cases. It's just a simple variable equals answer, one solution. Okay, good, no problems. No problems. But we did have a little bit more algebra going on. Hopefully you picked up on that. Here's example number 2. 7 over x plus 10 equals 5 over x. Let's go ahead and cross multiply. I get 7 times x, and I get 5 times x plus 10 x plus 10. Okay, and so what I get is 7x is equal to 5x plus 50. Do not forget to distribute. That's the biggest error that people make. Let's move our x's to the left. To the left. All the x's in the equation in a box to the left. If you're a Beyonce fan. We get 2x equals 50 after subtracting by 5 on each side. We'll divide by 2, and we get 25. X equals 25. Cool beans. Whoop. There we go. All right, not too bad. Not too bad. Just a teensy-weensy bit more algebra, okay? A couple of practice problems for you here. Try these, see what you get, okay? Okay, hopefully on this one you got 8. If you cross multiply, 2 times x minus 5 gives you 2x minus 10 if you remembered to distribute. And then you had to combine your x's. This one, you know, I did the opposite of what I normally would do. I usually move this x over here, but I was like, hey, what if I just subtract 2x on each side? Our tendency sometimes too can be move all your x's to the left in a linear equation. That's fine, you can do this. But here we get a negative x, and after I go ahead and add 2 to both sides, to get negative 8, we just divide by negative 1. So I wanted to put this up there in case you got stuck or you made an error related to moving your x's to the left-hand side. But anyway, you should have got 8. Did you get it? Cool beans. Let's go ahead and look at this practice problem. Again, a practice problem. Pause me. Try this example. Okay, I got negative 7/5. Is that what you got? You had to cross multiply. Distribute, and you get 7x plus 14. I went ahead and again I just moved that 7x over here, made it negative 10x, and then I divided by negative 10 to give us negative 14 over 10. If we reduce by 2, you get negative 7 over 5. Yes, you have to reduce. I know you're going to ask it. I knew it. Okay, let's go ahead. Let's look at some of the weird situations that pop up when we're working with these. Or I shouldn't say weird, just more unique, more rare. Like the holographic Charizard from the base set, you know, in 99. I never opened it, you know. I should have bought more booster packs. You know, they were only like $4 back then. Anyway, whatever. Let's go ahead. Let's cross multiply here. So I get 2 times x plus 1 if I do my cross multiplication here, which gives me 2x plus 2. Okay. And then on the right hand side, if I get 2 times x plus 3, so 2 times x plus 3 gives me 2x plus 6. And then I'm going to go ahead and solve. Let's move my x's over here. Let's move it to the left side. So subtract 2x, and I get 2 is equal to 6. Whenever this happens, I'm always taken aback. Like 2 equals 6, what? I first pause to make sure I didn't make a mistake, right? I need to move my x's together, so I do the opposite. Subtract 2x, subtract 2x. Yeah, positive 2, take away 2 gives me nothing. They both cancel. This is the no solution situation. No solution. So this is a completely false statement. So when you get this, there is no solution. Okay, that's a no solution. All right, let's look at this example. 7 over x equals 14 over 2x. I'm going to cross multiply. I get 14x is equal to, over here, 7 times 2x gives me, 14x. Hey, 14x equals 14x when? Always. So this is the case where we have infinite solutions. I can plug in everything in here, and except for 0. X can't be 0. 0 is a bad boy. If I plug in 0, it causes problems in the denominator. So sorry, 0, you're excluded. But this one's infinite solutions where x is not 0. Okay? Always true statement. I should have another one. It's failing to materialize. Ooh, we got more. Give me more. Okay, here's a practice problem. Pause me. Try this one. Try this. This one's a good one. It's special. Try it. I'll show you the answer here. Okay, hopefully you got negative 7. On this one, you cross and multiply. We did have a little bit of distribution, 2x plus 2. I moved the x to the right-hand side here. It gave me x plus 2 is equal to negative 5, and then I subtracted 2. right? Subtract 2. If I have color, negative 2, that gives me negative 7. So x is equal to negative 7. There you are. All right, another practice one. Pause me here. Try this one. Let's see what you get. Okay, cross multiplying in this one, you get 5 times x plus 4, 5 times x minus 5. 5x plus 20 is equal to 5x minus 25. When you remove the x's, oh my gosh, I'm tired. You get 20 is equal to negative 25. That's a false statement, so we ignore that, okay? No solution. No real solutions. All right, here you go. Here's another practice one. Almost there. Please pause me. Try this one. Okay, looking at this one, I went ahead and I cross multiplied 12 times x minus 1, and I cross multiplied 2x minus 2 times 6. I can get that 6 there. Create a nice butterfly. And that, after distributing, I get 12x minus 12 equals 12x minus 12. Got rid of the x's. Negative 12 equals negative 12. Hey, everything's a solution. Everything except 1. We don't like 1 because if I plug in 1, that creates an excluded value. Don't worry too much about this piece. That'll be in the next lesson. We'll talk about excluded values. All you need to know, really, same answer. That's infinite solutions. Infinite solutions. Okay. Very, very last one. This is the last one. Please pause me. Try this example. Okay. I'm here. I figured, hey, let me have some fun doing this. I'm going to cross multiply. Negative 5 times x plus 5 gives us negative 5x minus 25. This is all going to be equal to, hey, I got nothing down here. Don't forget that that's a fraction. It's a fraction. So 1 times x minus 10, guys, newsflash, spoiler alert, it's just x minus 10. Okay, I have negative 5x over here. Oh my gosh, let's add one more. Why not? Subtract an x. Let the good times roll, as they say. Negative 6x minus 25 is equal to negative 10. We'll move the 10, add 2, 5. Add 2, 5. I get a positive 15. Is that what you got? Hopefully. I don't want to be over here doing this wrong. Sometimes it happens, though. It happens. I'm not perfect. Negative 6, negative 6. We get x equals 15 over negative 6. Is that what you got? Hopefully you did. Hopefully you said, hey, maybe let me simplify 2. I can reduce this by 3. Reduce by 3. Negative 5 over 2. Negative 5 halves. AKA negative 2.5. Did some of you guys go that far? There's probably one of you out there. Okay. Hey, that's it for this video. Hopefully you learned how to solve some rational equations that resulted in linear equations. That's what we had to do. We cross-multiplied, solved linear equations. We also talked about infinite and no solution cases, which are pretty unique. Okay? Give the video a thumbs up. Talk to you later. See ya.